Okay, 18.1.3, basic rules of integration. Now I have integrate fx plus or minus gs. I give you example. Example, say, if I integrate x squared plus x, can I integrate them separately and then add together? Can or cannot? Huh? Can or cannot? Can, right? So very simple. So now this is fx, this is gx. I can integrate them separately like that. Can? I'm sure you know this. Just formalize it, okay? Make sure you know. Plus or minus, whether this is plus or minus, it will still work. Follow? Yeah, whether it's plus or minus, it will still work. Some of you will like words, so it just means that I can split the integration over addition and subtraction. Addition and subtraction, yeah? Can you do it for multiplication? You think about it, okay? So that means I have two terms added together, I can split the integration up. Now, next one. What if I say I need to integrate 100x squared? Can I factorize the 100 out? Can or cannot? Can. Okay? Can. Okay, I can factorize the k out. As long as k is a constant, of course. Yep. That means we can factorize the constant multiple. Okay, we can factorize the constant multiple. Okay, this is something interesting for us to think about. What if now I have fx and gx as a product, not a sum? Can I integrate them separately? Don't answer me yet. Answer yourself, okay? Answer in your head. Can or cannot? What about, can I do this as well? I can factorize a gx out. Okay, I think the first question is, we answer this first one first. Can or cannot? True or false? Okay, now talk to your friend next to you. True or false? True? False? False, huh? False. Next. Can you prove your answer? Can you prove your answer? No, cannot. Only know it's false. Huh? You only know it's false, but cannot prove. Okay, I said it many times, huh? To be like Newton and like whatever the name is. To prove something is extremely difficult. To say that something is false, to disprove something is actually very easy. How? Counter example. Just give a counter example. So all you need to do is to give a counter example. And don't choose a very difficult counter example lah. Correct? How do we, I just let fx, if I say this is x, what do I get? Actually, when I integrate x squared, I actually get x cubed over 3. But if I integrate them separately like that, like the right hand side, I'll get x squared over 2, multiplied together, I'll get x4 over 4. Surely they are not the same. Do you know what I'm saying? Okay? So a simplest way to say that something is false is a counter example. Your left hand side is now x cubed over 3. But what about the right hand side now? I'm sure you can work it out on your own. Correct? You can easily work that out on your own. Okay, this is integrate x, I get x squared over 2. Integrate x, I get x squared over 2. Alright, the right hand side is this, integrate x separately. And therefore, integrate x, I get x squared plus c, x squared over 2 plus c, another x squared over 2 plus c. One look, you know this and this are not equal. Correct? One look, you can see that you multiply together, you get x4, you get x cubed here. Definitely they are not the same. Okay, let's take a look at the second statement here. Okay, let me use a simple example. Let's say, for example, if I have x4 dx, is it equal to 1 over x? Oh no, not 1 over x. Can I factorize? Can I just factorize x integrate x cubed dx? Can I factorize the x like that? So this is all we're saying. Can we factorize this x out of the expression like that? Can or cannot? Yes. Zoom in. Wow. Challenging me. Can. Try. Like that, can? Like that, can? Better, okay. Wow. Okay. Are these two equal? Obviously not. So, sorry. Therefore, this is also false. Okay, false. Am I going to prove it now? No. Okay, you're going to do it yourself. Okay? Okay, you're going to do it yourself. Okay, this one DIY, okay? Can you prove this on your own? Okay, this one? Just use this, okay? Just use this example. Can? So, can we go back here? I deliberately showed these two examples because you may think that, oh, plus or minus, I can separately integrate. And I can also factorize a constant out. But be careful, if this is not a constant, if this is a multiply sign, you cannot apply this thing. Do you follow what I'm saying? Okay, if it's a multiply sign, we can't. Okay, be extra careful. Example 1. Okay, look up. There are blanks here, that means something for you to copy, but let us understand the idea here. I highlighted the word hence. I highlighted the word exactly. Because finding the derivative of this is all shown here, all printed for you. I assume you can do it quite easily. Okay, let's look through the solution of differentiation. Is quite easy. Let's assume we got there. The key word here is hence evaluate this integral, which means you are to use this first part to solve this. That's point number 1. Second point, there is this word exactly. Exactly would mean that you cannot use your GC. Correct? Exactly would mean that even though you can use your GC to check the answer, you can't use your GC to solve it. It can't just be one line and then 3SF done. So, all I said in just now are in words here. Okay? Not a GC question. Okay? We want to see the integration process. Alright? Important. Okay? Okay. Now suppose we know how to differentiate this, answer done. Now look. Differentiate this, I get this. So therefore integrate this, I get back this. But the question now is, I want to integrate this expression here, -1. There's an additional -1 here. Right? Doesn't quite look like this, but similar. First thing we can do, can we split the integral out like that? Can or cannot? That means integrate these two terms separately because it's separated by a minus. Can, of course can. Alright? Can, right? Now, this is easy to integrate. Integrate 1, I get x. This looks like this, but not quite the same. Again, I repeat. Differentiate this, I get this. Therefore, integrate this, I get back this. Can we create a 3 over 2 here so that I can use this result? Because it's a hence. It is a hence question. I need to make use of the earlier part. So the idea here is, okay, I create, okay, wait, don't copy it. This one is easy. I add a 3 over 2 here, but these two cannot be equal. I add the 3 over 2 here, then I decide what factor should this be, such that this times this will give me that 2/3 done. Okay, I can actually use this idea, I factorize the 2/3 out. So this times this gives this. Always check by multiplying these two and get here. Why do I write the 3 over 2 here? Because I need to make this 3 over 2. From this step onwards, it's easy because integrate this is actually the earlier expression, and we're done. Okay? Common mistake. I want this, so I want the 3 over 2. Many of us, okay, some of us will say, oh, I want 3 over 2, I write the 3 over 2, and then I have another 3 over 2. Of course, we all know this is wrong, because this times this, you will not get back this, you see. But don't make this mistake. Don't make this mistake. Is that all right? Ken?